Now I would encourage you at this point to press pause and see if you cannot find the equation for the line that goes through these 2 points, -3, 5, and 4, 7, by 2 different methods at least. If not one, that's great. If you can find it by 2, even better. So go ahead and do that. Alright, now you're back. Let's try this then. So I have 2 points. The first thing I'll need to figure out is the slope, and the slope is going to be the rise. So as I go from 5 to 7, that's going to be 7 minus 5. That's the change in y. So I've taken point 2 over here and point 1, taking the y-coordinate for the second point and subtracting the y-coordinate for the first point. So then I consistently must do the same for the x's. So I'll take the x-coordinate for the second point and subtract very carefully the x-coordinate from the first point, and this gives me a 2 compared to -7, +7 there, it looks like. Well, that's not a very nice number, 2 over 7, but there it is. And I can now put into my slope-intercept form or my point-slope form as I like, and I will pick for the moment to use y minus y naught is equal to m times x minus x naught, and therefore I have my slope, which is 2 over 7. The x-coordinate that we are given is, I'll pick the easy one, 4, and we have y minus 7. Now if I need to, I can distribute and subtract across and add across and find some other form, but with 2 over 7 things aren't usually quite as nice. We'll have some larger numbers. One quick way is to multiply through by 7 to get rid of fractions, but then it multiplies 7 on y, so that doesn't get all that much nicer. So I think I'm going to avoid that as a general rule. Let's just see what would happen if we'd gone for straight y equals mx plus b form. We would have taken the slope that we found, which is 2 over 7, and then we would have picked one of the 2 points to work with. And again, I tend to pick the one that has no negative signs in it so that life is a little bit easier. So 7 is what y is, and x is 4, and then the unknown b. Oh boy. So now I've got 8 over 7. I'm going to subtract that. So 7 minus 8 over 7 is equal to b. Now I've got to think the least common denominator, so we have 7, so that's going to be 49 on top there. 49 minus 8 over 7. This is turning into a fair amount of heavy-duty fractional work, so that's going to finally be 41 over 7. And yikes, I guess I can finally now write the equation for my line doing this. This really does seem like an awful lot of work to get this form. And I now finally have y is equal to 2 over 7x plus 41 over 7, which is a lot of work. And I think you'll notice that this was almost no work. We found the slope, and then we just plopped in the points, and we were done. So I'd encourage you, unless you have a reason to go for the slope-intercept form, to use the point-slope form, which is over here. All I need is a point and a slope. Now the final bit would just be to remind you that there are some special cases, and those are the vertical and the horizontal lines. So a vertical line, which looks like this, is going to have, if we looked at the slope idea, there's only changes in y and none in x. So if I was doing some kind of a slope here, I would find that I ended up with some kind of a change. So my y2 minus y1 would look pretty good. I would actually have a change there. But my x2 minus x1, because they are the same x-coordinates, are going to give me 0 in the denominator, and I'll have some kind of a number in the numerator. Now we all know that this gives us some kind of an undefined slope. So when you go for a slope and you get 0 in the denominator, what that typically means is that you have a vertical line. Now the equation for that line is going to be whatever those x's were equal to. So it might be in this case that I have one point was 3, 5, and the other point that I was working with was 3, 2. And so I can see the consistent thing is that x equals 3, and that's the equation for the line. Now, the horizontal lines, so let's write that in now. There's our vertical lines. Now the horizontal lines are going to give us the exact opposite idea, which is that the numerator, the y-coordinates, are not changing. So in this case, I should have 0 over some number. And an example of this might be that I have the point 3, 5 again, except that the other point now is something like 8 and 5. So the two y-coordinates are what are the same, and therefore what is consistent is that y is equal to 5. So you can see that the vertical lines have the consistent idea that x is equal to some number, so the equation is simply x is equal to whatever that number is. And when you're looking for horizontal lines, you can see that y is the thing that remains the same as unchanging, so the solution will be y is equal to some number. Now just a few final reminders. When you're all done, you do want to make sure that your equation makes sense. And making sense would mean that if you have a slope that is greater than 0, so if you end up with a slope of, say, 2 or 3 or 4 or 5, that your line should be going up as you move to the right. That's what we would expect, is to have some kind of a positive slope, and that the equation matches with the shape that I see. And likewise, if I have a slope which is negative, something like -2 or -3 or -4, that I would expect to see that my line is going downward as I move to the right. That's an important little check there. Another thing to be checking is if you have an intercept, that if your intercept is positive, so when you're using b, let's pull up a b here now, so if b is greater than 0, that your line should be intercepting the y-axis above the origin. So it would make sense if b is greater than 0 in y equals mx plus b that your line lives above the origin here. And likewise, that when you're done, if you have b is less than 0, that you would expect to see your line living somehow or crossing below the origin. So those are just little reminders as you go along here. And that pretty much concludes the basic equation writing. There are other forms to be considered, and we'll do that in a future video, but let's remind ourselves finally that the forms we are used to are y equals mx plus b, which we call the slope-intercept form. And we also have the point-slope form, where the information we're given is the slope and the intercept. Sorry, the point there, the slope. And we will come back to fancier forms and other forms, but these are the two major forms we see most of the time. And I hope you've enjoyed this video, and good luck on all the work.